That's absolutely correct. We should do other problems, yes, unless we need to go back for whatever reason.
We can do 13.
Okay, very good. 13 is 13 on page 480, and we have d of x equals x minus 4 squared, and we have s of x squared plus 2x plus 8. Good. So we're asked to determine the consumer surplus and producer surplus at the equilibrium point. So let's go back and read the question. So we have to find the equilibrium point first. Okay, part A, the equilibrium point. Part B, consumer surplus at the equilibrium point, because the consumer surplus can be determined at other points as well, like the producer surplus can be determined at other points. The procedure is the same. But they want us to find the equilibrium point and determine both at the equilibrium point. So how do we start? What is the starting point here? Anyone remembers what is the starting point?
You have to set them equal to each other?
Exactly, because the equilibrium point is exactly where this is the price and this is the number of units and this is the price per unit. So at this point, both of them are equal to each other. Okay. Same y value. Okay, so then x minus 4 squared must equal x squared plus 2x plus 8. Please remember a binomial squared has 3 terms. So 3 terms, which means x squared minus 2 times the first times the second, plus the second term squared. And of course, I will simplify. I will move 2x and I will move 16. When I move 2x, it becomes negative. So then I have 10x. Of course, negative. When I move 16 to the other side, it becomes negative. So I have negative 16 plus 8, negative 8. So then x appears to be 8 divided by 10, or 4/5. Unless I copied something, this is a little bit weird, but let me just go back and look at 13. Did I copy everything correctly? It's very possible. X minus 4 squared. X squared minus 2 times the first times the second. I'm checking, plus the second term squared. And the other one, x squared plus 2x plus 8. X squared plus 2x plus 8. Good, I copied it correctly. So we subtract x squared. Negative 8x minus 2x is negative 10x. And 8 minus 16 is negative 8. So then 8 divided by 10, I simplify by 2, and I get 4/5. So the equilibrium point has x 4/5. Now I have to determine the y value. It doesn't matter where I plug it in. I can go back and check, and it has to be the same number. So 4/5 minus 4. So 4/5 minus 4 squared. So 4 minus 20 divided by 5, everything squared. And we have negative 16 over 5, or 16 squared over 25. And I want to check the other one just to make sure. I don't see any error, but let me just check the other one as well. So 16 over 25 plus 8 over 5 and plus 8. The least common denominator is 25. This needs a 5 and this needs a 25. Lazy people use calculators. So 16 plus 40 and plus 8 times 25. Oh, no, too much. Okay. So 256, they are correct because 16 squared is also 256. So that's what it is. So this answer is 256 over 25. Weird, but possible. So we got the equilibrium point. So that was part A. In part B, we have to, in part C, we have to find the producer surplus. First consumer, it doesn't matter. The order is not important. And producer surplus. The consumer surplus is the integral from 0 to 4/5 from the demand function, but I'm going to write it like this. Dx minus this product minus 4/5 multiplied by 256 over 25. The producer surplus is this product 4/5 times 256 over 25 minus the same limits of integration, of course, but not from this function because we're talking about the producer surplus, but from this function. So from x squared plus 2x plus 8 dx. And we will get these numbers. Any questions so far before we determine the two final answers? Any questions?
No.
The steps are okay? The numbers are weird. Sorry,
Yes.
I even checked just to make sure that there is no error. Okay, so then I'm just going to show it with the graphing calculator so we can move on to other problems. Unless you say no, it's up to you. You tell me. Do you want me to use the graphing calculator on these two or not? We can do both. You let me know if you change your mind in the meantime. So number 9, the integral from 0 to 4/5. Be very careful, as I said, the calculator has limitations. In just one class, with another class I told you, we found 2 limitations. Quite disturbing. Okay, dx. And then minus. Careful how you write this product. Minus. Parentheses. 4 times 256. 4 times 256. Close the parenthesis and divide by parentheses. 5 times 25, you can multiply, it's 125. Okay? 125. And close. And that has to be a positive number, and it's 2.22. So the consumer surplus, of course in dollars, $2.22 cents. Now for the other one, I was just thinking if I can copy anything from there, but it doesn't work. Okay, that's okay. So 4 times 256 and divide by, if you don't write the product, you just multiply 5 times 25, which is 125. You don't need parentheses. But minus, now number 9, the integral from 0 to 4/5 from the other function, which is x squared plus 2x plus 8. Dx. So 98 cents. So producer surplus, 98 cents. Good, it was a very good pick. As I said, I wasn't expecting those numbers, but it is what it is. Very good. So this was a consumer and producer surplus situation. Do you need any help with any problems? I'm hoping you looked at the written homework solutions and so on and so forth. You choose the next topic, whatever you want. Any topic. Any questions? Anything you want to go over? Anything? David, Michael, would you like to choose anything? Is there anything you need help with?
One second, I'm checking.
Anything, any topic, you name it.
Can we do implicit
Differentiation. Yes, 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 yes. So let's do the implicit differentiation, and then Michael, you can, after we choose an implicit differentiation, you can choose any problem, any topic. So that gives you a little bit more time to find what you are looking for. Okay, a situation with implicit differentiation will be something like x to the third y plus 2x squared minus 3y to the fourth equals 2x. We cannot solve this equation for y. So if we're asked to find dy over dx, then I know you can put a little dot under this function, and you know it's a function, and be careful when you differentiate. So when I differentiate both sides, because that's the only way, here I have to use the product rule. X cubed prime is 3x squared times the other function, plus x cubed. I got to this. Please do not write y prime because it may get lost in the translation, as we say, right? So please use this notation, dy over dx. When I differentiate this, there is no problem. It's just for x. But when I differentiate 3 or negative 3 times y to the fourth, multiply, negative 12, subtract 1 from the power. But since this is a function, you have to multiply by the inner function prime. And please do not write y prime, but write dy over dx. When I differentiate the other side, that's easy. It's just 2. Now, remember, we are after this variable. So these two terms will stay on this side. This one goes, this one goes. Because it does not, these two don't have the variable. So therefore, and then I factor out x cubed minus 12y cubed. I factor out this because I cannot combine these. So I have no choice. Over dx equals 2, but minus 3x squared y and minus 4x. Now it's done because I solved, this is just algebra. So dy over dx has to be this over this. This is the number that multiplies dy over dx. It has to go to the denominator. And this has to go to the numerator. And that's it. Now, if I'm given a point, so let's say, I don't know, because it has to verify the equation. So let's say I'm given the point a comma b, and I'm asked to evaluate this a comma b. I will replace x by a, y by b, x by a, x by a, y by b, perform the calculations, and get a number. Is that okay?
Yes, thank you.
Perfect. Michael, if you found something, please let us know.
Yeah, I wanted to look at
Yes.
finite linear, like volume, and I think it was with linearization.
You said the linearization?
Yeah.
Okay. So do you have a problem for us? The linearization is a linear function and is determined with f of a plus f prime of a x minus a. So you have to give us a function, f of x, any function you want, and you have to give us a. Any A you want.
Okay, let me do
I can,
2x.
I can tell you
2x
where the
minus
linear approximations are if you want. And
yeah.
then you can choose. They're in chapter 3. And they're on page 341. I can share my screen as well. 341. Where's my book? 341. So we can pick any function. It doesn't have to be any of these. You can choose any function you like and any A you like. And we can find the linearization.
Can we do sorry, can you go back up?
Yes. These are not linearizations.
Can we do
Which one?
no, number 22?
Number 22. Very good. Awesome. So for number 22, f of x or h of x, it doesn't matter, is 1 over the square root of x. And a is 4. Perfect. So remember, this has to be immediately replaced by x to negative 1/2. Because we can't differentiate something like this. I mean, we can, but you don't want to use the quotient rule for that. So this is the formula for the linearization. Meaning, in f of x, I have to plug in 4. So this number is 1/2. This number is 4. So this piece is x minus 4. The only one that I'm missing is the derivative because I don't have the derivative yet. And I have to plug in 4 in it. And put this number in and it's done. That's all I need to do. So I'm going to find the derivative. F prime of x. I have to bring down the power and subtract 1 from the power times the inner function prime, but that's 1. So in order to find this, I have to plug in 4. A is 4. So f prime of 4. I have negative 1/2 in front. And this is 4 to negative 3/2, or 1 over the square root of 4 to the third power. Okay? Well, the square root of 4 is 2. 2 to the third would be 8. 8 times 2 is 16. So f prime of 4 is negative 1 over 16, which makes this number negative 1 over 16. And I have the entire linearization. I just have to put it together. So L of x equals 1/2 minus 1 over 16 times x minus 4. Don't forget parentheses here. I have to distribute, so I have negative 1 over 16x, but when I multiply these two, I have positive 1 over 4. 1 over 16, 1 over 16 times 4 over 1, I simplify and I have 1/4. I cannot forget that, so plus 1/2. So this is the linearization so far. I have to find the least common denominator, which is 4. I have to multiply the top here by 2. So the linearization is negative 1 over 16x plus 3/4. What does this mean? If this is the function f of x, at this point with x 4 comma f of 4, at this point, the equation of this tangent is this. The equation of this tangent can approximate the function very close to 4. If you say use this when x is 7, I'll say I can't. I have to determine another one at 7. I have to determine this one at 7. If you say use this when x is 1, I'll say I can't. It's too far away. I have to determine another line at 1. But very close here, I can use the linearization to approximate this function.